Welcome back, guys. You are still watching Lecture 3 entitled Gravimetric Methods of Analysis. At the end of this lecture, you are expected to understand gravimetric factors and use them in your calculations. So basically, what we will be dealing with in this section are calculations involving gravimetric data. To better understand gravimetric calculations, we will have a brief recall of stoichiometry. In stoichiometry, the mass of a certain substance, let's call A, can be converted to a mass of another substance B if they are related or connected through a chemical reaction. Kailangan alam natin ang reaction involving substance A and B for stoichiometry to be done correctly. Also, kailangan balance muna ang chemical reaction before you perform stoichiometric calculations. Recalling the steps, first, mass of A is divided by its formula weight to get the moles of A. Then it will be multiplied by the stoichiometric ratio of the substances involved to get the moles of B. This ratio will come from the balanced chemical reaction. Then it will be multiplied to the formula weight of B to get the mass of B. This set of steps can be easily remembered if you recall the rule, kailangan nagka-cancel ang units. It is again emphasized in this lecture video that units are important in calculations. The discussed processes are also applicable in gravimetric calculations. A and B can be replaced in the equation by the precipitate and analyte respectively, as shown in this slide. Rearranging these stoichiometric steps will lead to the formation of a factor called the gravimetric factor. Again, walang bago sa gravimetric factor. It is still stoichiometry na nire-arrange lang ang steps. To better understand their similarity, we will highlight each part of the gravimetric factor. First, this A over B factor here corresponds to the stoichiometric ratio of the analyte and the precipitate. Next, the ratio of the formula weight of the analyte and precipitate corresponds to these steps in stoichiometric calculations. Sa first part ng stoichiometry, naka-divide si formula weight ni P. Sa last part naman ay naka-multiply si formula weight ni A. Combining these two will result to the ratio of the formula weights in the gravimetric factor. Lastly, the gravimetric factor is also equal to the ratio of the mass of the analyte and the precipitate. In stoichiometric calculations, they are usually the unknown and the given mass. For this lecture, we will still use stoichiometry but in the form of gravimetric factor. We only need to remember this simple equation. You should also note that gravimetric equation or this gravimetric equation is not only limited for analytes and precipitates. It can also be used between two reactants or two products as long as they are related or connected by a chemical reaction or a chemical formula. To better understand this equation, we will try to use it in solving problems in the succeeding slides. But before we go to calculations proper, we will have a warm-up first. Listed in this table are the different gravimetric factors depending on the substance being weighed and the substance being sought. Let's focus our attention first on the first gravimetric factor. Determination of this factor is not possible if you do not know the reaction involved between the precipitate silver chloride and the analyte chloride ions. The reaction between the two is given by, here we can see that the stoichiometric ratio between the analyte and the precipitate is 1 over 1. Substituting this ratio to the formula for gravimetric factor, we will get molecular weight of Cl over molecular weight of AgCl. Next, let's focus our attention to the third gravimetric factor. Here, the analyte is Fe3O4 or magnetite, while the precipitate is Fe2O3 or hematite. Huwag masyadong kakabahan kapag nakakita ng mga more complicated compounds. Parehas pa rin naman ng steps na gagawin natin sa kanila. Baka kasi yung iba, pag nakakita ng ganitong formula or reaction, ay mahematite bigla. Okay, wali. Moving on, we can see that the stoichiometric ratio between magnetite and hematite is 4 over 6. Simplifying this will result to 2 over 3. That is the reason why the gravimetric factor resulted to this form. I think we already had enough warm-up. Let's try to do some real stuff. For guided problem number 1, we are asked how much silver nitrate, AgNO3, is needed to convert 2.33 grams of sodium carbonate, Na2CO3, to form silver carbonate, Ag2CO3. We are also asked to get the mass of the silver carbonate that will be formed. The answers are given, so you can pause the video and try to solve this on your own. As mentioned earlier, solving gravimetric or stoichiometric calculations will not be possible if you do not know the reaction involved. In this problem, the reaction is represented by the following reaction shown. As CHE students, the next step after seeing the equation is correct, to balance the equation. Since we already know the balance equation relating the substances, we can now solve for the mass of silver nitrate. Let's recall the formula for the gravimetric factor. As mentioned earlier, gravimetric factors is not only limited to precipitates and analytes. Pwede rin sila gamitin for two reactants, like in this problem, gagamitin natin siya for silver nitrate and sodium carbonate. Let's replace A with silver nitrate and B with sodium carbonate. This ratio of mass is equal to 2 times the formula weight of silver nitrate divided by 1 times the formula weight of sodium carbonate. This equation contains only one unknown. Solving for the mass of the silver nitrate, we will get 7.47 grams silver nitrate. We will now employ the same process in getting the mass of silver carbonate. Let's recall again the formula for gravimetric factor. Inuulit-ulit talaga natin para hindi makakalimutan ang formula na to. Let's replace A with silver carbonate and B with sodium carbonate. The ratio of this mass is equal to 1 times the formula weight of silver carbonate divided by 1 times the formula weight of sodium carbonate. This equation contains again only one unknown. Solving for the mass of silver carbonate, we will get 6.06 grams silver carbonate. So now we have already solved guided problem 1. Let's try to solve another guided problem. Here we are asked to solve for the percent potassium chloride in a 0.25 gram of impure sample. The impure sample was reacted with excess silver nitrate and yielded 0.2012 grams silver chloride. In this problem, silver nitrate is the precipitating agent and it is added in excess to make sure that all the analyte KCl will be precipitated out. The answer is given so that you can pause the video if you want to solve it first on your own. As discussed previously, gravimetric calculations are not possible if you do not know the chemical reaction involved. In this problem, it is given by the following chemical reaction. Don't forget the next step, to balance. And if you would check, this reaction is already balanced. The same series of steps will again be employed in this problem. Let's recall again the formula for gravimetric factor. Ayan. So nakailang ulit na tayo, so sana ay hindi na talaga makalilimutan. Let's replace A with potassium chloride and B with silver chloride. The ratio of this mass is equal to 1 times the formula weight of potassium chloride divided by 1 times the formula weight of silver chloride. The equation contains only one unknown. Solving for the mass of the potassium chloride, we will get 0.1047 grams potassium chloride. Looking at the problem, we are looking for the percent KCl in the sample. Recalling the formula for percent KCl and substituting the calculated mass of the potassium chloride and the given mass of the sample, we will get 41.9% KCl. So now we have already solved guided problem 2. Let's try to solve again another guided problem. Here, we are asked to get the weight percent of C and H in the sample. It is also mentioned that the unknown compound produced carbon dioxide CO2 and water H2O upon combustion. The answer to this problem is already shown. Again, you may pause the video if you want to try this on your own. In this problem, we will try to have a different approach in solving. Another way of relating the substances in gravimetric factors is by looking at their chemical formula. Instead of getting the whole reaction, you can simply look at their relationship based on their chemical formula. Carbon C will be related to carbon dioxide using the formula shown, while hydrogen H will be related to water using the given relationship. The same series of steps will again and again be employed in this problem. So first, let's remember again the formula for gravimetric factor. Let's replace A with carbon and B with carbon dioxide. The ratio of this mass is equal to 1 times the formula weight of carbon divided by 1 times the formula weight of carbon dioxide. Again, this equation contains only one unknown. Solving for the mass of carbon, we will get 3.93 milligrams of carbon. Looking again at the problem, we are looking for the percent carbon in the compound. Recalling the formula for percent carbon and substituting the calculated mass of carbon and the given mass of the sample, we will get 68.78% carbon. Again, we have already solved the percent carbon. The same steps will be done for percent hydrogen. Recall the gravimetric factor formula. Substituting the givens will result to 0.281 milligrams hydrogen. Again, recalling the formula for percent hydrogen and substituting the calculated mass of hydrogen and the given mass of the sample, we will get 4.92% hydrogen. Now, we have finished solving guided problem 3. Let's try to solve another problem similar to guided problems 1, 2, and 3. Here, we will try to solve for the gravimetric factor either by using the balanced chemical reactions or by just looking at the chemical formula. The answers are already provided, so you can pause the video if you want to try to solve on your own. The following relationships can be obtained from the problem. First, to solve for the percent Fe, iron can be related to hematite Fe2O3 using the following relationship based on their chemical formula. Next, to solve for percent magnetite Fe3O4, the calculated amount of iron can be related to magnetite using the following relationship. Lastly, we will also try to solve the percent magnetite using the balanced chemical reaction. If you can recall from the table presented earlier, I already omitted the other substances involved in this reaction to highlight the stoichiometric ratio between hematite and magnetite. Let us first try to solve for percent iron in the ore. Hindi na natin ilalagay ang formula for gravimetric factor. Hopefully ay na-memorize na natin siya by now. Diretso substitute na ng mga givens. So substituting the givens will yield 0.375 grams of iron. Recalling the formula for percent iron and substituting the calculated mass of iron and the given mass of the sample, we will get 33.14% iron. The same set of processes will be done in calculating percent magnetite. Substituting the calculated amount of iron and the givens from the problem will result to 0.521 grams Fe3O4 or 0.521 grams magnetite. Recalling the formula for percent magnetite and substituting the calculated mass of magnetite and the given mass of the sample, we will get 46.04% magnetite. Now, we will try to solve this percent magnetite using the chemical reaction approach. Substituting the given mass of hematite instead of the calculated mass of iron will result to 0.521 grams magnetite. If you can remember from last slide, the same amount of magnetite was also obtained. Thus, solving again for percent magnetite, we should get the same answer, which is 46.04% magnetite. From the guided problems that we have discussed, it can be observed that as long as you can relate the substances, either by balanced chemical reaction or by simply looking at their chemical formula, you can use the gravimetric factor in solving the unknown amount of substance. Siguraduhin lang na balance ang mga species before mag-solve. I guess that is all for Lecture 3B. Thank you for watching and see you in our next synchronous discussion. Bye!